Hi everyone, welcome back to my YouTube channel. In this video I'm going to discuss about sample size calculation for two studies. One is comparative study and the second one is cross-sectional study. First I will be talking about comparative study. Okay, here's a formula named McNemar's formula. It is for comparative study and it goes like this, and it goes to and is the minimal sample size. It equals to g alpha plus g beta whole square into p1 plus p2 upon p1 minus p2 whole square. The value g alpha and g beta are almost fixed. It changes only when you change the confidence interval and the power of a study. If you take confidence interval as 95%, you have to take g alpha as 1.96. Similarly, if you take the power of a study as 80%, you have to take g beta as 0.84. If you change the confidence interval into 90% or 99%, g alpha value changes accordingly. Similar case with the g beta. If you change the power to 70% or 90%, g beta value changes accordingly. The remaining p1 and p2 values you have to take from the similar studies which have already been published. P1 stands for proportion of discordant pairs shifting from positive to negative. P2 stands for proportion of discordant pairs shifting from negative to positive. So what are these discordant pairs? Before going into that, let's choose a topic for our study. Let's say we are going to do a comparative study of MRI findings versus arthroscopic findings in knee injury. Okay, we all know that arthroscopy is the gold standard test for knee injury, and we are going to compare our MRI findings with that. Okay, so what are these discordant pairs? Now let's understand this. There are two values, p1 and p2. P1 stands for positive to negative discordance. P2 stands for negative to positive discordance. For this I have taken a value from a similar study which have already been published, and the topic says this comparison of MRI findings with arthroscopic findings in derangement of knee. Okay, it has been published in QS in 2023, and the results says in diagnosing ACL tests, for ACL tests MRI had sensitivity and specificity of 88 and 76% respectively. So I have taken this value only for the ACL tear. Okay, MRI has sensitivity of 88%. It means out of 100 cases of ACL tears, MRI could detect 88%. Sensitivity means true positive. It means out of 100 cases of ACL tears, MRI could detect only 88%. It means remaining 12% are detected as non-ACL tear. Okay, it means though the remaining 12 cases are also the ACL tear cases, it is detected as negative by MRI. So this is the negative to positive discordant. Okay, MRI has a specificity of 76% in detecting ACL tear. It means, specificity means true negative. So let's say there are 100 non-ACL tear cases. Okay, so MRI could detect only 76% of such cases. It means remaining 24% of non-ACL tears are detected as ACL tears by MRI. It means MRI detected it as positive, but in reality it is negative. So this is the positive to negative discordant pairs. Okay, so you have to take value as this way. P1, it means positive to negative. You have to take this value 24%, and this negative to positive discordant P2 you have to take 12%. Okay, either you can put those value in this formula and calculate the sample size, or there's a calculator which is called MedCalc. I've already installed this app and I'm using the free version. And here you have to go into sample size and go into the McNemar's test. Here you have to put the value. So type on error, alpha error. So we are taking 95% confidence interval. It means the alpha value is 5%. It means 0.05, and the power we are taking 80%. You can take if you want to decrease the sample size, you can take 70%, as power, which is 0.7, and P1 which was 25%, and P2 12%. So now let's calculate. It came out 153. So the sample size is 153. Okay, so this is about finding sample size of comparative study. Now let's move into the cross-section study. I have one article which was published 3 years back. This is my own topic, my own article, which was about finding prevalence of tympanic membrane perforation, and I had used a simple Cochran formula for calculating the sample size, and it is goes like this. N stands for this minimal sample size, which equals to G square into P into Q upon E square. G is the value which we have to put according to the confidence interval, and P stands for the prevalence of the tympanic membrane perforation in the other study. Okay, so I have taken this study from the Indian study, because I couldn't find such similar cases in our Nepal. You can take that way. If you can find similar study in your own country, you have to take the value of prevalence from that study. If not available, you can take it from your neighboring country. So the prevalence of tympanic membrane perforation in an Indian study was 54.85. So I took it as this one, and P and Q stands for 1 minus P, which is 0.46, and I took the margin of error as 5%, and the sample size was it came out as 381. But I had a little bit more samples, so I put this way. The minimal sample size was this much, but however a sample size of 414% was taken for this study, because N is the minimal required sample size. You can take more than this, but you cannot take less than this. Suppose you work in a clinic where the patient flow is very less, and you want to do a study in a lower sample size, or let's say you are going to do a very rare study, and you think you are not going to have such so many cases, so you want to take lower sample size. Then what you can do is you can take the 90% confidence interval. It decreases your sample size, or what you can do is you can increase the margin of error up to 10 or 20%. This way also you can decrease your sample size. So you can calculate this way the sample size of your cross-section study. Thank you very much for watching my video. If you have any comments, if you have any feedback, you can comment down below. Okay, thank you everyone for watching my video. Thank you.